In this lesson, we're going to continue talking about different types of firewalls. Remember that a firewall scans incoming and outgoing network traffic and compares that traffic to the rules you've defined in the access control list. Then it decides whether the traffic should be allowed or rejected. The level at which a firewall scans network traffic depends on the type of firewall being used. There are several different types of firewalls that you need to be familiar with. We have packet filtering firewalls, circuit-level gateways, and application layer firewalls. First, let's talk about packet filtering firewalls. A packet filtering firewall examines the information within each packet header. It operates at layer 3 on the network layer of the OSI model. When a frame enters a packet filtering firewall, the firewall removes the framing information to expose the IP packet contents within that frame. The packet information includes the data, the destination IP address of the packet, and the source IP address of the packet, as well as the source port and destination port. With a packet filtering firewall, you can define ACLs based on that information that's contained within the IP packet, including the source IP address, destination IP address, source port number, and destination port number. Every packet that comes into the firewall is compared to ACL rules you define. These rules specify whether to allow or reject these packets based on the network interface that the packet was received on, the direction of the communication, whether it's inbound or outbound, the source IP address, the destination IP address, the source port number, or the destination port number. For example, the firewall could be configured to allow all packets from a specific source IP address. Alternatively, maybe you could define an ACL that blocks all inbound traffic that's destined for port 22. Be aware that these are very simple ACL rules. You can define very complex ACLs with many different rules for evaluating packets. For example, you could block all packets through source IP address just from an external network and only allow communications from hosts that are on the same subnet as the destination host. Be aware that many routers actually provide a packet filtering firewall. They're basically a router and a firewall all in one, providing both functions. Because of their ability to filter by port number, a best practice for packet filtering firewalls is to actually block all ports and then open only the ports that are necessary for network functionality. For example, let's suppose you have a web server on your network. Therefore, you might want to block all ports in the firewall except for the one that's used by the web server, port 80. There's a second type of firewall you need to be familiar with. This is called a circuit-level gateway. A circuit-level gateway filters traffic based on the session's state, not the IP address or port number, like a packet filtering firewall. A circuit-level gateway makes filtering decisions based on the session layer information, which is the session ID number. The firewall only allows packets that match after sessions. In order to do this, the circuit-level gateway has to take advantage of the TCP three-way handshake. To establish a TCP session, a client computer first sends a request for a session with a very special packet called a SYN packet. The server responds back with an acknowledgement, an ACK, which says, "Yeah, I have a session available and you can use it." The client then responds with another acknowledgement called a SYN ACK, which acknowledges that it received the original session information and it wants to establish communications with the server. This is important because the circuit-level gateway monitors this three-way handshake process to identify an active session, one that's set up, acknowledged, and in use. When a packet is received by the firewall, it'll move the packet header information just like a packet filtering firewall does. This time, it's going to examine the session information within that packet. If that session packet represents a legitimate setup session and it's currently active and in use, then that communication is allowed. If it finds a session ID that is not active, that was never actually created, or that's already been closed, then that packet is dropped. Instead of examining every single packet and filtering based by rules, a circuit-level gateway just looks at the session ID and decides whether or not it's associated with a legitimate TCP session. A circuit-level gateway is very useful because it protects your network against network attacks such as SYN flood attacks. A SYN flood attack attempts to manipulate that TCP three-way handshake in order to instigate a denial of service attack. Even though a circuit-level gateway filters at the session layer of the OSI model instead of at the network layer, it's actually faster than a packet filtering firewall. This is because a circuit-level gateway only filters by one single value, the session ID. In contrast, a packet filtering firewall must sort through a long list of different values in an ACL, such as the IP address, port number, and communication direction. The final type of firewall we're going to look at is the application layer firewall. An application layer firewall, as its name implies, operates at the application layer in the OSI model. Application layer firewalls do not filter packets by IP address or port number. Instead, they filter by the application layer data within each packet's payload. Messages that enter the firewall are typically composed of multiple packets. At the network layer, a packet filtering firewall examines each packet and makes forwarding decisions based on the ACLs you've defined. At the session layer, a circuit-level gateway examines the session IDs associated with information across multiple packets. At the application layer firewall actually takes all those individual packets and reassembles them into the original data. Then it makes forwarding decisions based on what's in the data. Let's look at an example. Let's suppose that this firewall is filtering HTTP requests, or web page requests. An HTTP request can be something as simple as, get this specific web document from this website. The application layer firewall reassembles that request when it comes through, creating the original document. After that's done, the firewall can go ahead and evaluate what's actually in that document, and then make filtering decisions based on what it finds. For example, the firewall could filter the website based on content. This could be as simple as blocking a specific URL, or it could use a list of predefined terms or words to specify what's blocked. This could be very useful if you need to block specific categories of websites, like online gaming, online gambling, or websites with adult content. This is also useful for blocking games or other applications that may have been reconfigured to use traditional ports for connections. For example, we may have an online gaming application that's been reconfigured to use port 80 instead of its default dynamic port because most packet filtering firewalls have port 80 open for web pages. This would allow that application to get past a packet filtering firewall. However, because an application layer firewall inspects the contents of each packet, it can identify specific application signatures and block those applications even if they're using an allowed port. Another feature of this type of firewall is the ability to allow or deny access based on users and groups. Application layer firewalls are often referred to as proxy servers, which is just a specific implementation of a particular type of application layer gateway. A proxy server sits between a network and an end user. For example, we may have a network of computers over here that need to access information over here on the internet. The proxy server sits between the internet and these clients. All of the requests going to the internet from these clients are intercepted by the proxy server. The proxy server will take those requests and use application layer filtering to decide whether the request should be allowed or blocked. These filters could be based on the URLs being requested or the users that are making the requests. For example, you could configure your proxy servers so that only certain users are allowed to access the internet. You can take it a step further and only allow them to view certain websites. A proxy server may also be configured to cache frequently accessed internet content. When a user accesses a particular web page through a proxy server, it can actually cache that data locally. Then, when another user on the internal network tries to access the same web page, the proxy server pulls the page out of its cache and delivers it to the end user without going out on the internet to get it again. That saves bandwidth. There's another type of proxy server called a reverse proxy. It works a little bit differently. Instead of filtering internal requests headed out to the internet, a reverse proxy handles requests traveling from the internet to internal servers. For example, here we have a reverse proxy server that's sitting in front of these web servers. Let's say a client out here requests access to one of these servers. Instead of that request going directly to the server, it first goes to the reverse proxy server. The reverse proxy server looks at the request, and then, depending on what was requested, it will connect to the correct server. Basically, it creates a link between the client and the server. One thing to be aware of about reverse proxy servers, and proxy servers in general for that matter, is that they operate transparently. The client doesn't know that they're connecting to a proxy server. As far as it knows, it's connecting directly to the server over here, either on the internet or on the internal network, depending upon whether we're using a reverse proxy server or a traditional proxy server. One thing to be aware of about proxy servers is that they operate transparently. That means that the client doesn't know they're connecting through a proxy server. As far as it knows, it's connecting directly to the server. One thing to remember is that reverse proxy servers can be used to cache information, just like a regular proxy. Also, reverse proxy servers can balance the load being placed on internal web servers. A small to medium-sized business may invest in a Unified Threat Management device, a UTM. A UTM device combines multiple security services all into a central device. It may include firewall, anti-spam, antivirus, load balancing, VPN services, and so on. Combining all these services into one single device makes managing all these services a lot easier, and it lowers the overall cost of ownership. You only have to manage one device. However, a UTM device also creates a single point of failure in your network. If the UTM device fails, then you'll lose every single service it provides. Because of this, larger organizations usually employ individual devices, one for each security service that the organization needs, in order to create a layered defense. As you can see, a firewall can protect either a single host or an entire network from external threats. It can also protect against internal threats. That's it for this lesson. In this lesson, we learned about different types of firewalls and the different ways that you can implement a firewall on a network.